Hello everyone, my name's Daniel and I'm a programmer and an artist. This video is part 3 of my series on modular modifiers. We are working on making a set of modifiers that will let you create and customize procedural roads or paths or anything along those lines. So far we've set some general parameters in a road base node for like the width and stuff, and then we have made two different versions of a road surface modifier that fill in that boundary outline with a mesh. A lot of my ideas for other modifiers that we could make are going to require placing objects on or along curves. So whether that's like lines in the center of the road or a curb around the edge or a railing next to that. And one of the things we're going to want to do when we're working on those modifiers is be able to offset a curve. So we're going to want to be able to take this boundary curve here and push it further out away from the road. Of course, that creates a problem in the corners because in corners, what happens if you push the curve out along its normal or whatever, rather than going here where we want it to, this point will get pushed out here and this point will get pushed out here, and it'll actually create this weird loop effect like this. And obviously that's not what we want. But other than my trick in the first video where I showed how you could create a boundary from around a volume, well, if you convert the curve to a volume and then to a mesh and then just take the boundary of that, that's how we got our boundary curve. Other than that trick, I don't know of a good way to do this, and I don't think converting this to a volume will work in this case because it would be hard to... Well, first of all, it's kind of slow, so the whole system would get laggy, which isn't great. And also, we wouldn't be able to just create a volume around this curve and then take this outer point, because we would get a double curve like this. So we would have to do something weird like create a volume again around our center curve and then add to that a volume around the outer curve and then take the outside of all of them. That could be something we could do if we really needed to be accurate, but I think there are some tricks we can use. There's not a perfect way to solve this overlapping problem, but there are some tricks that can make it much less likely to happen. So anyway, I've been going on for too long. My plan today is to first make a curve offset node that will allow us to push that boundary curve in and out. And then I also want to make a node that allows us to split that curve up into segments that we could instance things on or things like that. So we might get to that node as well. So those aren't going to be modifiers, but they'll be helper nodes that we'll use in multiple modifiers probably. So let's get started with that. All right, first thing to do to get started, let's just add a new geometry node setup. And I want to be able to work on the boundary curve without worrying about separating things. So I'm just going to make a geometry nodes here that takes our roads util, which I should rename to have a space in it, because then I can search for util and that will come up much faster. So we're just going to take that and take the boundary curve. This will essentially delete everything else out of it. And we'll just save this. And that way, if we just want to work on a new node and we don't want to worry about it being part of our modular roads thing, that's where we have to like delete mesh parts and things, then we can add that, get the boundary, and experiment with it until we're happy. So now we can add a new geometry nodes group and make a new node group, which currently we're using as a modifier, but won't be eventually. And we'll maybe call it curve offset. And my idea for how we can do this is to provide the user with iterations value, that the more you increase it, the more accurate the offset becomes at the cost of time, because it's going to take longer to do it. So we're going to want a repeat zone to do that. Now we need to know, first of all, what direction we want to push this in. And I think to do that, we're probably going to go back to the base node and transfer the mesh, the terrain normal to our curve. So let's take a look here. Let's draw an arrow and take a look at this. So this is drawing by default the normal, and we can see that the normal of our curve is pointing like at a 45-degree angle, which is kind of interesting. But let's actually go back to our road base and see if we can't capture the normal of the raycast on it. So after we delete the parts that aren't, so if you remember on our road base, we had the parts that were sticking off the edge, and then we deleted those. Right after we delete those, let's capture, let's set the normal of the curve. This is a new node that's in 4.1, which is pretty sweet. I really like it. It's a lot simpler than trying to set the tilt, which was how you would have to do this before. We can just take our normal of our raycast, which is off of the terrain, and we can apply that to our curve, setting the normal mode to free, and then we should be set. So if we go back to if we add these modifiers back on, now you can see all of the normals for our curve match the normal of the terrain underneath it. So that is not the direction that we want to offset in, but if we put the normal in here, we can see that's the same. If we do the cross product, though, of the normal with the tangent of the curve, so, and again, the tangent at any point on the curve runs along the curve. The normal is pointing up more or less, so the cross product of those will be perpendicular to both, this way. But I'd like it to point outward, so let's do the tangent first and then the normal. All right, now we have a direction for every point in our curve that tells us which way is outwards, away from the road. But this is where our problems will be. Now, set a set position in here and just lift this up a little bit. We get something weird going on here. So I wonder if that's two curves. Let's try also in here, see if we can delete any splines. Delete spline if the length, curve length, the spline length point count is less than, say, like 10 or something. Does that get rid of this? Yeah. So that will help us. So I think what happened was we merged, this was a mesh originally, this curve, which was the boundary of the outside of the remeshed volume. And then we merged by distance. And so this got merged. We had three going into a single point here. And so when that gets converted to a curve, curves can't have three edges coming into a single point. So it got separated into its own thing. I wonder, let's just look at the spreadsheet too on this spline. It's not cyclic either, so I guess we should make this cyclic. I guess it was filling the boundary anyway, so I don't know if making it cyclic is strictly necessary, but seems like that would make sense. In fact, I wonder if there's duplicate points there now. I wonder if a better way to do this would be to mute these, and when this was still a mesh. So here we merged by distance. I wonder if we should, would we ever have, we should never have a vertex with only one edge coming out of it. So here we can delete a point if the neighbor, vertex neighbor's vertex count is less than 2, we can just delete that point. And that will get rid of that. Then when we convert it to a curve, it won't have any problems, so it should be cyclic. And we can just skip all of this deleting and stuff at the end. Typically, if you can fix a problem earlier in your node tree, it's better to do it there than to wait and fix it later. All right, so now we're back to working on our curve offset tool. So we've got now our curve and the normals are pointing the right direction, and the curve is closed, and we don't have any extra splines in there because we deleted all the points. Actually, I just realized there's another problem, potentially. If you remember the way this was, it was here, it had 1, 2, those were connected, but then the third one came out to a point. But what if there was another point here? We'd be deleting this one, but then that one would still be there. So I guess we just hope that never happens for now. All right, we need to add the cross product of the normal and the tangent to the position of our curve as an offset. That'll give us this, and if we scale it, then we can adjust how much it moves. So this is what we want. We are creating a new curve that's further away from the road than the original curve. But it's got this problem in concave corners. So the first thing we want to do is expose the scale value to the input, because that's going to be our offset distance. And this can be a distance. It can be positive or negative. But let's set these to some sort of reasonable values like -5 and 5. Remember, again, they can always type something else in there. All right, so now we have on our node or a modifier a value we can change to control the offset. Then if we have a number of iterations, we can put this inside of here, our repeat zone. Say we want to do that, though, over a number of iterations instead of all at once. Well, we can divide our offset by a second input that we could call iterations or quality or something like that. And we should set a max to that that's somewhat reasonable, like 10, because if you set it high, it could really freeze Blender for a long time. So then if we divide our offset by the number of iterations, then we should move it whatever distance we set, but in increments. So if we change this number, then the curve should stay in basically the same place, but we are moving it there over time instead of all at once. Now, the way we can try to get rid of this loop is by resampling the curve as we move it. So might notice if we move this a little bit instead of a lot, that we don't have the loop. Let's add a set position back in here to lift it up again. So we only moved it a little bit. We moved it 0.1, so it originally was here, and we just moved it a little bit. If you do that, then you don't get the overlap. So if you do it in increments like that and resample at every step, then in theory, you can offset it without getting the loops. However, we'd also like to sort of optimize that process so that we only have to resample it as few a number of times as possible. And so there's a couple other tricks we can do as well. And one of those is the fillet curve, which is sort of like a bevel for curves. And we can drop that in here. Now, I think we should base the size of that off of the number of steps, potentially. So let's try multiplying the offset size per step, which is our offset divided by the number of steps, by like 0.5, and using that as the radius. Then let's resample the curve to a length that is, try the length of our offset and see what that does. And then after we've set the position, we're going to want to resample it again so that, so when we do the bevel, that rounds out a corner. But now there's a lot of points, and if there's a lot of points, they're more likely to overlap when you offset them. So then we resample it to reduce the number of points in the curve. Then we move them outward, which pushes the points closer together again. So then we have to resample again before we do the fillet, or the bevel on the curve. At least that's the idea. So now if we set this to a large value like 2, and then we increase the quality, it didn't really help, which is unfortunate. But what if we multiply the offset times 2? Because increasing the length helps. All right, that kind of works. So let's try it with this and see. So if we set the bevel size to be 1/4 of the offset per step, and then we set the resample size to be double the offset per step. Then we actually get there with just 1 step, but it's higher quality if we do it in 3. And let's just double check that that's working everywhere. We could also edit our roads here a little bit, make something a little more. Now that's interesting, that created a problem. Now we've got a problem where this curve is going the wrong way. So that's an interesting problem. How could we solve that? Also, let's try going -1 on this. Interesting, it doesn't work at all. Oh, I guess we should do, this needs to be absolute for our resample. All right, -1. So we can kind of actually offset inwards as well, which is good. All right, but this is a problem here. This curve's moving the wrong way. How could we detect that? Because we need to reverse that curve. But if we just reverse the curve, then it will make the outside go the wrong way. So if we go here and we do reverse curve, then our outside is going to pop in instead. So we need to reverse the curve, but only, in this case, this curve. So we need a way to distinguish between the curve that's going the right way and the curve that's going the wrong way. The way that we could do that would be by sampling the point the way we can do that is we can capture a vector on the curve, or not capture, we can just get a vector, we can calculate a vector on the curve. That is the curve's tangent with the cross product of the normal after we make the normal upright. That's either going to point, depending on which way, if the tangent is pointing this way or if the tangent is pointing that way. So either going to point this way or this way. Then we can get a vector from our original, the nearest point on our original control curve to our new point on this boundary curve. And we can compare if the dot product of that nearest point on the control curve and the cross product of our tangent and the normal of the terrain are pointing in the same direction or opposite directions. And then we can use that to, we can convert that into a Boolean value to control which curves get reversed. I think that'll work. So, all right, so to do that, we have the normal here. So the curve normal is right. So let's see, I guess we're gonna want a greater than for a float. And we're gonna want a dot product. And we're gonna wanna do the dot product of a cross product. And the cross product should be between the tangent of the curve and the normal. And then we got to sample another vector off of, which is going to be based on a direction. So we're going to want to normalize a subtract. And that's going to be the position minus the nearest point on the control curve. So let's see. This is our control curve. So we're gonna have to move all of this over. So here we need to sample nearest. This needs to be a mesh to mesh. Sample nearest index, sample index. This is the index. We want to sample a vector. We want to sample the position. And then that should give us this position. Okay, is that working? I think it's working, but we're reversing the wrong one. So let's switch our greater than to a less than. And now all of our offsets are moving in the correct direction. All right. Show our timings. I'm curious what's slow here. 200 milliseconds. Probably the volume merged by distance. What if we got rid of merge by distance and just resample the curve? Because that would also solve the problem. So merge by distance was what was causing the problem here, where we had the 3 points going in, or the 3 edges coming into one vertex. So if we get rid of the merge by distance, we solve that problem. And then it's also a slow. So the only reason that was there was to try to clean up the jaggedness from the volume to mesh. But I think just resampling the curve does that just as well. So yes, that's better. All right, so now we have a curve offset node. The other node, so let's just save that so that we have it. Don't need this. The other thing we might want to do probably is raycast that against the terrain again, because even though the cross product of the normal and the tangents gets it approximately right, especially like here where there's a hill, it put it underneath. So, but I think we'll do that on, well, we'll probably want to do that pretty much every time. All right, let's add a way to raycast to this. So let's add a collection info. This is going to need to go to the input. That should be relative. We want to realize it. Then we can just do a raycast. And we can raycast from the position, add like 50 on the z-axis so that it starts above. And then, oops. Here we can do a domain size, because we want this to be optional. So we look at the number of instances in the collection. If it's greater than 0, we'll do a switch. If that's true, let's do a set position of this to the hit position. And let's just use the isHit, I guess. And then that'll be our new output. And if we don't have any instances in the collection, we will just skip that entirely. All right, so now if we come here, we can select the terrain. And now everything lines up with the ground again. All right, now that we have that, the other thing I wanted to be able to do was divide that curve into segments, potentially with randomized lengths for being able to put like curbs and things on each segment. So my idea for what this would do is essentially that you'd have an input curve, and approximately every whatever distance, 1 meter or whatever, 2 meters, we would divide that into sections. So then this would be a curve segment, and this would be a curve segment, and this would be a curve segment. And then I could use my instance on curves node to place objects on each of those curves, like a curve section from a collection or something. Or, yeah, I don't know. That's all I've thought of so far. But that's one of my ideas. So, but I don't have a curve. I have the curve dash node that kind of does this, but it's makes exactly the same length segments. So I think I want to try to do it a different way. My idea is essentially that you could create a line that was the same length as the curve, and then resample that line to have a number of points where the length of each section of the line was whatever length you decided, just using a resample curve length. And then we could offset the positions on that line by whatever amount we wanted. And then we could evaluate the curve at each, where we calculate a factor for how far, well, or we could even just probably use directly the factor of, because the curve, the line and the curve should be the same length, so we can just use the factor of the line to go into the factor of the sample curve, and then we can reposition the line to where the curve is. And then we can delete, or we don't need the original curve anymore, we can use our segmented one. So let's see about making that. So we can add a new modifier, and we'll call it curve segmenter. So let's see. We're going to need a line, curve line. It can be one long. Then we're going to want to duplicate that. We want to duplicate the spline. How many splines do we want? Well, that should be based on the domain size. Domain size of the curve. How many curves are there, or how many splines are there? We want that many lines. Then we need to sample index off of the spline. And we want a value at the index of at our duplicate index. We want the spline length. And then we want to take our geometry and set the position. This is a curved line. It starts at 0 and goes to 1 on the z-axis. So we can just take the position and scale it by our spline length to get a number of lines where each line is the same length on the z-axis, same height as the length of whatever curve it's assigned to. So that gives us this. You can see we have these curved lines going way up into the sky. Next, we want to resample the curve. And we want to do that based on length. And the length should be exposed to an input. And I think something like 2 is probably good. Single value. Then once we've resampled that, we want to offset the points in the curve by up to half the length. So let's multiply the length by 0.5 and plug that into a random max, and then we want to multiply that by -1. Actually, this should be the max, this should be the min. We can expose the seed to the input, just because that's always a good idea. And then we can plug this into a combine XYZ in the Z, and then we can do a set position on our points of our curve, and we can do a selection. We want to do all of the points that are not the endpoints, because we don't want to, if we move the endpoints, we change the length of the curve. So not the endpoints, but everything else can move up or down a random amount. And so now that value we should scale, and we should expose this to the input. And this will let us control how random it is. So we'll call this randomness. And it should be a factor between 0 and 1 with a default of like 0.25 or something, single value. Now if we draw points on our curve, we'll be able to see this working. That is a lot of overlapping points. Let's change the length to 2. So then if we change the randomness here down to 0, you can see that all of the points are evenly spaced. And then as you increase the randomness, they move random directions, which changes the length of each segment between them. So then once we have that, we want to capture an attribute on it that will be the factor, because we're going to split it apart and then all the factors will get lost after that. So we've captured the factor, which should match exactly the factor of the curves we want to copy the position of eventually. So then if we make this a mesh, to mesh, then we can do split edges, and then we can do to curve to make it back into a curve, and then we can do what else do we want to do? Probably set curve radius to 1 because that always gets deleted. Probably want to transfer the normal. So let's do another capture attribute. It should be a vector. We want to capture the normal. And then we want to set the normal free. Bring this over. What else? Then we can do set position. Then we want our original curve from all the way back here. So let's just copy this. And we will do a sample curve. The curve we want to sample is based on our duplicate index here. So add a reroute. Let's bring this up here. So we want to sample whatever curve our duplicate index is. The factor should be this factor that we captured here. And I don't think we want to sample. Actually, we could use that normal. Oh, that actually makes way more sense. We don't have a normal here. So we can't capture the normal there, but we can set the normal to the normal that we sample here. And then we want to set the position to the position that we sample. And then we can also give them a way to increase the resolution of this. So we can put a resample curve before this. And let's set the number low to like 3 because this could make it slow. And this count can be called resolution. Should be a single value with a max of like 12 or something. All right, so if we draw arrows on this, our normals should still point upwards, which they do. Where did the center line come from? Oh, this isn't in there. Normals still point up. We're matching the terrain, which is good. But we've divided that into segments. I think often, if you're going to instance on it, you would only want the resolution to be 2, and it'd be straight lines. But if you wanted to deform something on it, then you might want a few more in there. The other thing that would be handy to do is to be able to trim this curve. So let's do a trim curve. I always like length better. And I think it would be fine to just trim both sides at once. So we want to trim the end to be the length, spline length. Subtract whatever our offset is. So then we can set this to like 0.1, make that an input. And we'll call this spacing. And then let's multiply it by 0.5 so that the space is the distance that we set here. This should be a distance. And it should go from 0 to, I don't know, 2. It's probably fine. So then, just so that when you type in a number, the distance that the two curves are apart is actually the number you type in and not something else. We will multiply that spacing by half, subtract that from the length, and then we'll do trim the start to half the offset and trim the end to the length minus half the offset. So now we should have this spacing. And if we use that, let's do another set position here and lift this up. So then if we increase the spacing, you can see that we get gaps between our curves. All right, so I think that is where I'm going to call it for this one. We didn't make a whole lot of progress on new modifiers, but we've made some useful tools that should help us with making more modifiers in the future. So hopefully that was interesting. I know there's some like little fiddling in there trying to solve little bugs and problems, which hopefully that was interesting to see sort of how I think through doing that. But yeah, progress a little bit slower, but it's all necessary to get there to the end result. So in the next one, maybe we'll try to do curbs and see what we can come up with for that. Anyway, that's all I've got for this one. Thanks for watching.